Here we are at example 1 from our 0.3 set of notes. We're asked to solve the following, and we notice that we have an equation here where we have our two different sides, and we're trying to figure out what is our y value. Now, in order to do this, we see that we have a bunch of different fractions here. Some things, like for example this 4, it technically is a fraction. It's the same thing as saying 4 over 1. And we all know that we really don't enjoy working with fractions. And so one thing that we're going to go ahead and do is we're going to go ahead and multiply both sides by the LCD. So most teachers and such, they call it the LCD. Personally, I prefer actually calling it the LCM, and we're going to see why in a moment. So now if we look at our bottoms, again, we don't like fractions. The end game is to try and get rid of the fractions. And then we want to just pretty much look at those numbers. So we have 2, 1, and 2 again. So the smallest thing that 2, 1, and 2 all go into is 2. Because 2 goes into 2, 1 goes into 2, and 2 goes into 2. So what we're going to go ahead and do is multiply both sides by that number 2. That would be technically our LCD, 2. But again, I really prefer the term LCM, and the only reason for that is because I think it usually helps students remember that we're talking about a multiple for these denominators specifically. Okay, but you can use LCD if you want to. Now, when we multiply 2 times 3 gives us 6 divided by 2y. That takes care of the left side, equals. On the right side, we're going to go ahead and distribute. So the 2 times the 4 gives us 8 over 1. Remember, the denominator stays the same. And then the 2 times the 1, when we distribute it to the half, gives us positive 2 over, keeping the denominator 2, y. So again, the green line is pretty much just distributing that LCD or LCM to both sides. Now we're just going to go ahead and simplify this up. So 6 divided by 2 gives us 3 y's equals 8 divided by 1 is still just 8 plus 2 divided by 2, that'll just cancel out, and then we end up with 1y. Now our end game here is to actually go ahead and try and solve for y, but we notice that we have a y on the left side and we notice that we have a y on the right side. Well, we want to get all the y's on one side, but at least now in the blue line we don't have any fractions to have to deal with, so that's kind of a blessing there. Keeping our variable positive, again, we talked about the little strategy, so let's go ahead and subtract this 1y from both sides, because then our variable will become positive 2y on the left side equals 8. And then lastly, we're just going to go ahead and divide by that coefficient of 2 on both sides. So 2 divided by 2, they cancel. Y is then by himself equals 8 divided by 2 on the right side gives us 4. So there we have gone ahead and solved for y. Again, that is example 1 from our 0.3 set of notes.